All right, let's get right into it. We're going to unpack a really fascinating mystery in the world of AI. And it turns out the solution is something surprisingly simple, a trick that researchers are now calling the training wheels trick.
So have you ever had this happen? You're in a deep conversation with an AI, maybe you're summarizing a long document or you're trying to write some code, and all of a sudden it completely forgets what you were talking about just a few minutes ago. It's super common, and honestly, it's pretty frustrating.
Yeah, that's not just a random glitch. It's actually a hard-coded limit on their memory. Now, your first thought is probably, okay, we just need to add more memory, right? Build a bigger, more complex AI. But what if the real breakthrough here isn't about adding something, but about taking something away?
At the very heart of this problem is a term you've probably heard thrown around, the context window. The easiest way to think about it is like an AI's short-term memory. It's the scratch pad, where it holds all the information for the current conversation. But once that scratch pad is full, the old stuff just falls off.
Okay, so for an AI to even understand what we're saying, it has to know the order of the words. I mean, dog bites man is totally different from man bites dog, right? The way it does this is with a clever little tool called Positional Embeddings. You can call them PEs for short. They're basically like little digital tags that tell the AI which word comes first, second, third, and so on.
And this is where things get really interesting, because it turns out these incredibly useful positional embeddings, well, they're a double-edged sword. The very same thing that's essential for helping an AI learn is also the thing that's putting a lock on its memory.
And we've got the data to prove it. Take a look at this chart. It shows two AIs learning from scratch. See the red line? That's a model using positional embeddings. The blue line is one without them. It's not even close, right? The model with PEs learns way faster and just gets a better result. They give it this huge head start.
But here's the crazy part. This chart shows what happens when you test that same model's long-term memory. Look at that red line again. As long as you stay within its comfort zone, that's everything to the left of the dotted line, it does great. But the second you ask it to remember something just a little bit past that limit, its performance completely falls off a cliff. It just catastrophically fails.
So what do you do when the solution is the problem? Well, this leads us to this radical new idea from a team of researchers at a place called Sakana AI, and they call it the training wheels trick.
Their whole idea, which is a wild one, is stated right here in their paper. They basically say, hey, what if these positional embeddings aren't actually a permanent part of the AI's brain? What if they're not an inherent requirement and can be safely removed after the main training is done? It's a huge idea, just taking out a part that we all thought was essential. And their method, which they call DroPE, is just beautifully simple. Here it is. Step 1, you train the AI with the PEs turned on, just like everybody else does. Think of this as learning to ride a bike with training wheels. Step 2, once the model knows what it's doing, you just drop them. You take the training wheels clean off. And then step 3, you just let the model wobble for a little bit. A really short period where it just fine-tunes itself and adjusts to this new reality.
So the core idea from the team at Sakana AI is this. PETs aren't the permanent foundation of the building. They're more like the temporary scaffolding you use while you're putting it up. And once the building is stable, you can just take the scaffolding away. Okay, it's a brilliant idea in theory. But the billion-dollar question is, does it actually work? I mean, can you really just rip a core component out of a highly trained AI and somehow expect it to get better? Well, let's see what happens when you put DroPE to the test. And the results are, well, they're just night and day. On the left, you've got a leading memory extension technique called yarn. See how its accuracy just completely tanks as soon as it goes past its training limit? Total failure. Now look at the right. That's DroPE. It just sails right past that original limit without so much as a dip. The difference is absolutely stunning. So what is this test they're running? It's a pretty brutal one, actually, called the needle in a haystack test. Researchers literally hide one specific, unique sentence, the needle, somewhere inside a massive document full of random text, the haystack. Then they just ask the AI, hey, can you go find it for me? It is a pure, raw test of memory over a long distance. And this wasn't just a one-off fluke. When they tested this across a whole bunch of different long memory tasks, the results were crystal clear. The standard model, using that yarn technique, it got an average score of about 20. The exact same model with the DroPE trick, it scored over 30. We're talking about a more than 50% jump in performance. That's huge. And you might be thinking, okay, sure, that's cool for a small lab model. But this isn't some niche trick.
The researchers proved that this scales up beautifully to the massive billion-parameter models that we're all using today, like Llama 2 7B. This is a technique with serious real-world potential.
So let's zoom out for a second. Let's look at the bigger picture here. Because a simple, elegant trick like this could have some really profound implications. And maybe, just maybe, kick off a whole new era for how we think about and build these models.
So why should you care about this? Well, for one, it could unlock massive AI memory without having to do a super expensive retraining from scratch. 2, you can apply this to models that already exist out there, giving them an instant memory upgrade. All of this makes powerful AI with long memory cheaper and faster to build for everyone. But for me, the most exciting part is that it forces us to question our basic assumptions about what's actually needed to build an AI.
And that really leads to one final big question. We just found out that a part of AI we all thought was fundamental is really just a temporary helper. It really makes you wonder, doesn't it? What other essential parts of our technology, both in AI and everywhere else, are actually just training wheels, waiting for us to get good enough to finally take them off?